The broadcast is now starting. All attendees are in listen-only mode.
Okay, welcome everyone to this webinar with Snowflake and Datalytics. My name is Anthony Schneider. I'm a solution architect at Snowflake. So I'm there working with our partners like Datalytics on the platform. And we have Sam, Matt, and Robert from Datalytics who are going to show you a bit of a practical demonstration of the product in action. So I'm just going to give you a brief introduction of Snowflake, of the platform. We were founded in 2012, so a relatively young product, but we've had enormous growth since then. We've had 2 rounds of venture capitalist funding, totaling $463 million US. Our first customers were on the platform in 2014 with general availability in 2015, but we're now growing to over 1,300 customers, and that's just growing every day. So I think that may even be out of date. So we're saying huge growth in the platform, which is exciting. So what are we and what is Snowflake? Snowflake is a SQL database built for the cloud. So ANSI SQL compliant, so very easy to do those migrations off existing platforms. Your SQL analyst will find the platform quite easy to use. So a SQL database, data warehouse at its core. We pride ourselves on the amount of management that you don't need to do to run this platform. So we classify that as zero management. So there's no vacuuming of tables, no indexes. Those DBA type activities go away in Snowflake. No infrastructure to manage either. So the idea that you can be up and running in Snowflake in minutes, start loading your data in and get insight from your data immediately is a real strength of the platform. All of your data is another USP that Snowflake has. So we have support for semi-structured data inside the platform. So the idea that you can load your JSON data, your XML data, your Parquet data directly into Snowflake tables and start querying that on the fly is a really powerful element of the tool. But then again, we are a data warehouse at our core. So all your structured data, your CSV data, in whatever volume that may be, we can take that into our platform as well. All of your users, we have some really exciting features around concurrency, the ability to handle large amounts of users hitting the database, let's say on a Monday morning, and scaling up to meet that demand, but then scaling back down when and if the database isn't required. So you're only paying for what you use per second on the platform. Also, Sam will show you a bit about our virtual warehouse architecture and that ability to segregate users, let's say, from your data science community, from your BI community, so that they're not competing for resources. They can have their own dedicated compute. Paying only for what you use, as I mentioned there. So per second billing on a compute perspective, and we on-sell Amazon or Azure Blob Storage in terms of our tables and the data storage. So very cheap to store large volumes of data, and then only paying for the compute that you use to access it. Finally, we have a very exciting feature, data sharing, recognizing that the movement of data between you and your data consumers is very difficult. We have a unique functionality that allows you to do secure data sharing with other consumers so that they can instantaneously be granted access to that data with zero contention on your own resources. So the ability to share large petabytes, terabytes of data instantaneously with your customers without any FTP or S3 bucket sharing is a very exciting feature. In terms of our geographical strategy, we are deployed in these AWS regions for the time being. So a couple of locations in Europe there, in Ireland and Frankfurt. We're growing that rapidly based on customer demand. And you'll see Azure in there. We're also crossing clouds to deploy in the Azure cloud as well there. Lots of customers, lots of uptake in various industries. So Capital One is our largest financial institution on the platform. So they're doing some very exciting stuff from a data science perspective in Snowflake. But we're really seeing all verticals take up the platform now, whether that be small data volumes to very large data volumes like Localytics there, who are storing petabytes of data. So some very exciting uptake on the platform. And just briefly on the architecture, which I touched on there. At its core, we have 3 layers. One is the storage layer, which is your tables, schemas, columns, everything that you're used to within a database. But the way that we're able to scale so dramatically is because we're built on the blob storage system within the cloud. And that separation of storage and compute there is so powerful from a Snowflake perspective. We can scale this system out at any time of the day during live runtimes without impacting anything that sits on disk. So there's no need to redistribute data on disk or any of that. So the idea that you can throw or take away compute on demand instantaneously without impacting any of the table storage on disk is a really powerful feature that allows us to scale really quickly and dynamically. So that's the compute layer, the virtual warehouse layer we refer to. That's the layer that does all the processing. So you can spin up as many of those virtual warehouses or compute layers and access the same set of data in the table storage below. Finally, we have the service layer, very important layer, ACID compliant database. Needs to understand all writes that are happening, all transactions that are in process, all the security and all the metadata management around those tables and those structures. So a very important layer that is our service layer where all queries are executed through. And finally, a good example of what our customers are doing with Snowflake to try and drive some ideas. We do see a lot of customers coming in with an existing landscape, of course, and we do see lots of those consolidating all those data marts or those data silos that they've created, usually because of performance challenges. They've had to aggregate their data in a batch window and bring it into separate tables and separate data marts. We're seeing a lot of people reducing that complexity on their ETL, just because our platform's so fast. We have some very unique, cool caching capabilities that you can actually hit the raw data and still get the performance that you require. To modernize your data warehouse, so actually replacing an EDW, we see a lot of that. We are a cloud database, so if you're making that move into the cloud, we strongly recommend that you look at Snowflake as an alternative to actually host and be the core data warehouse platform in the cloud. Finally, I talked a bit there about semi-structured data and our support for that. We do see a lot of people struggling with the complexity of Hadoop or struggling with the complexity of having multiple NoSQL databases to support that data. The idea, again, of simplifying that architecture and going straight and dropping into Snowflake, into tables, using our variant data template for that semi-structured data, but then also their structured data as well, and consolidating that all in one place, means that they can have Snowflake at the center of their architecture and have a very simple software as a service data platform. So that's probably a very quick, brief intro to Snowflake. Now you want to see, I guess, how all that works. So I think it's best for me from here to hand over to Sam Hopper at Datalytics, who's going to show you a bit about the platform, how it operates, and get you playing on it. So over to you, Sam.
Thank you, Anthony. Yes, so my name's Sam Hopper, and I'm the lead architect at Datalytics. So we're a London-based company that partners with organizations such as Snowflake to deploy and manage solutions and instances of database data systems generally. Okay, and what I'm going to do today is run you through a demonstration. This is 0 to Snowflake in 90 minutes. I'll probably keep it near 60 minutes to allow some time for questions at the end. But essentially what we're going to do is go through from nothing through to a setup of Snowflake with some data in there, with some BI hanging off the back of it and all the usual things that you'd expect to see, but we're going to do it in about an hour. Okay, so let's kick off. If I just advance my slides, there we go. So what's the scenario? So I've put together a fictional scenario here just to colour things in. We've got this fictional company, ZTS Limited. They have been in server monitoring, network monitoring for quite a long time, and they've got some great technologies and some great algorithms for detecting events and throwing out alerts, that kind of thing. So in the sort of the traditional server networking, some satellite as well in that sort of space. More recently, they've made an acquisition. Acquired a company that's doing tracking and monitoring of physical assets, like particularly vehicles, so cars, trucks, boats, planes, yachts, drones, all that sort of stuff. So they found that actually their technology and their algorithms are a great fit, but the trouble with that is they've got loads more data now, so their database is really creaking. It's on sort of some legacy on-prem technology. They're looking to move their data warehouse onto the cloud, and they're looking at Snowflake. and that'll let them drive more of the great sort of reports and dashboards that they do currently, and push those out wider into their end customers and end users as well. Okay, so that's the scenario we're working from. What we're going to build. So we're starting from a couple of sets of data. So this is, it might be a proof of concept, let's say. So they've given us some data, some asset data, which is data about the physical assets, the vehicles, or other items that we're monitoring and tracking. And we've got some event data. So this is the raw event logs that have come out of this system that we can then put in and process. So this is sitting in an Amazon S3 bucket. So this is outside Snowflake. We've got an empty Snowflake instance. It's just got a user, an admin user, that we'll use to log in and start setting things up. And what we're going to do is we'll set up a database, and that database will have 3 schemas to show the different layers of a sort of abbreviated modern data architecture, where we'll ingest the data, we'll structure it into a curation layer, and then we'll put a BI consumable view or table in the calculation layer. To do that, we'll need some processing. So we'll need some virtual warehouses to actually process the data. We'll bring it in, we'll process it, and we'll then set up a BI tool. In this case, we're going to use Zoom Data as a real-time BI platform that we can use. That will just hook up to the calculation layer table that we'll create, and we'll set up a dashboard that we've got in there, so we can see the data actually going all the way through from the source into BI. And there's some other stuff we'll do along the way. So essentially, that's what we're going to do. That's what we're going to set up, and we'll walk through that, and then we'll have an opportunity at the end for any questions. Okay, so let's kick off. Step 1: create the database. So we're going to create, as I said, create this database with the 3 schemas, and we're going to hook it up to the Amazon S3 bucket and use that as a stage. So if essentially there's 2 types of stage within Snowflake, and a staging area is an area just literally to store files. Files normally that you'll either stage in or stage out of data tables within the database. And you can either have internal stages, which are managed by the Snowflake platform, or you can have an external stage, which could be an S3 bucket or Azure Blob Storage, which you'll then hook up to Snowflake, and Snowflake can then see the contents and interact with that as if it was a stage that it was managing itself. The big difference being that you're paying for the storage externally on Amazon, as opposed to using internal storage within Snowflake. Okay, the other thing we'll need is we'll need a CSV file format specification, just so we can understand how to read these files. So we'll set these things up now. If I just switch screens, I'm going to go through into, where is it? There it is. Okay, just going to log into Snowflake. So like I said, we've got a Snowflake account here, and we're going to log in as Alex, who's our fictional admin user, and just go through there. And what that'll do is that'll take us to the Snowflake UI. What I'll do is I'll just give you a very quick tour. There's not much in here at the moment, so but you'll see along the top we've got these 4 buttons. So start with databases. Databases gives us the list of the high-level database objects that we've got, and if we go into any given database, we can then go into the tables, the views, schemas, stages, and so on. Within each one, we can see also which tables, which size of data, how many rows there are. We can even go down into the structure. So there's quite a lot we can do interactively within this UI to browse the actual database objects we've got and start to see storage sizes and that kind of thing. If we switch now to warehouses, we don't have any set up yet, but this is where we'll configure our virtual warehouses. So these are the pools of compute resource that we use to do operations like putting data in, processing data, querying data. At the moment, we don't have any warehouses set up, and we won't need one actually for a few steps in this process. We'll just be doing metadata operations. So if you remember from Anthony's overview at the start, the architecture is very much storage in the center. There's then pools of compute, the virtual warehouses sitting around the edge, and the whole thing is wrapped in the services layer, and it's that services layer that we're interacting with now. Okay, so this web UI is part of that layer. We then have the worksheet. We'll come onto the worksheet because that's where we're going to be running this demonstration from. Some of the items I'll set up using the UI. A lot of it, though, I'll use pre-written SQL statements, primarily for speed, just so we can bash through this quite quickly. Some of the less interesting bits, like creating databases and schemas, but also just to minimize the chance of error. I think you want to be able to see Snowflake doing some great stuff rather than seeing me debug SQL statements when I've made typos. So what we'll do is we'll just go through that now. Some of these things, though, like I said, I will do through the UI. So, for example, creating a database, we can do through the Databases tab. If I can back out to the top level and then hit the Create button, I can then put a name in. There we go. Not a lot to do. And interestingly, on this type of pop-up, you've got this Show SQL button. That will, I'll just recreate that. You'll see it does give you the SQL statement for pretty much anything you do through the UI. So if you want to start automating items, you can copy and paste the SQL out of here, tailor it, parameterize it, and put it into whatever automation platform you have. So it's all available. Okay, that's the database set up. Now we'll just set up these schemas. So in the worksheet here, I can just grab a bunch of rows, hit run, and it will run those in sequence for me. Oops, missed a statement, that's why. Okay, that's why I'm if I go off script and start doing things by hand. Let's see, let's set those schemas up. Okay, there we go. So I hadn't selected the database that I just created, so that's why it failed there. And if we just run a show schemas, we see we've got the schemas set up here. Calculation, curation, and ingestion. We also have public, which is the default schema. So if we try and create objects without specifying a schema, they'll go in there. And then we've got the information schema, which is where all the system views are in terms of the metadata for the database itself. Okay, so we've got our database. Let's go down a bit. Now we need to hook it up to our S3 stage. So I've got an S3 stage. It's in Amazon S3. Here's the URL to the bucket. I've also created an IAM user with key and a secret key, so I can hook up to that. And all I need to do is run that operation. That came back straight away. That's set up the stage. And in fact, if we go back to the databases view, click into ZTS, and then look on the stages tab, we'll see we've got the stage now. And can't see the secret key, of course, but there we go. We can edit the details if we want to. And if we wanted then to automate the creation of stages, we can click on Show SQL again. So we can get to all the underlying automation if we want to. Okay, so we've got a stage. Now, because that's linked to an existing S3 bucket with files in it, if we do the list command to list the contents, Snowflake will have already scanned that, and it will be able to draw us out a list of all the objects or the files in that stage, and which are the files from the bucket with the name, the size. It's even done an MD5 hash if we need to do any comparison operations or anything like that. And Snowflake will use that internally for operations like data loading to make sure it's not going to duplicate a data load. So that's used internally. So that's great. We've got 2,501 rows. So we know we've got assets and events in there. So we've got one assets file, and which is the top one there, and then the rest are events files broken down for us into blocks. So that's fine. We've got all that. The last thing we need to do in this step is just create the file format. So like I said, this is going to be to allow us to pass the CSV data. So we're going to tell it things like what's the field delimiter? Is it comma? New lines for between records. We're going to have a header row, so we need to skip that, and that kind of thing. So again, you can do this interactively through the UI, set these up, and that's normally quite a good way of doing it in a proof of concept. And you can do it through SQL as well, either for speed or for automation. So just create that file format. And let's just have a quick look again, file formats. There we go. And see those details there. So that's been set up. as a CSV format for us to use. We can have multiple different formats, and also we can have formats for different types. So it's not just CSV, of course. We might be able to, we might want to pull in JSON data, XML, or things like Avro, Awk, and Parquet from big data platforms as well. All these different types of formats we can pass. Okay, step one done. So we'll just switch back to PowerPoint. So that's what we've set up. We've set up the database. We've set up our schemas for our different MDA layers. We've hooked up to S3. So we've got our files accessible now in our ingestion layer, and we've created a file format that we can use to pass that data. Okay, moving on to step two. So now we're going to curate the data. So at the moment it's still in files in our ingestion layer. But what we're going to do is we're going to create a table. Initially for the events data, we're going to create a structured table to move that data into. We'll need then to set up a virtual warehouse to process the data. And we'll move the data in from the stage using that CSV file format and pass it into the table. So without further ado, let's switch over here. So first thing to do is create the table. So a very standard create table statements. If you're familiar with SQL, you'll know that there's nothing particularly unusual here. Snowflake has specific data types. It uses string or varchar interchangeably. There's very few numeric types. There's not a big wide variety of types. You can do it with a very small number. And there's great online reference if you want to have a read up about the different data types and how they map to the physical data types from other systems. Let's create that table, and we can do a describe on that, just to have a quick look at what we've set up. And again, if I just switch back out to the databases view and go to the tables view on there, we see we've got our table now, and we've got our fields, okay, but no data in it yet. We've just created the table. Right, okay, so all the way up to this point, we've not spent any money on Snowflake. So we've not stored any data yet inside Snowflake. Our data's still outside, and we've not processed any data. The only operations we've been doing have been things like DDL statements. So we've been just doing metadata operations, creating structures, and that kind of thing. So we've not actually incurred any cost. What we're going to do now is set up a warehouse. This warehouse, and it's important to remember the term warehouse is maybe a little bit misleading. It's not a data warehouse. There's no data inside the warehouse. It's really a pool of compute resource that you can use that will then allow you to get at the data. So there's no direct relationship between the virtual warehouse and the stored data in the databases within the system. So you can have various different warehouses accessing various different databases, assuming you have the permissions as a user to use the warehouse and to access that data, but there's no direct link. So let me just set that one up, and that's created that warehouse, and we're going to just make sure we can use it. So do a quick grant to make sure the admin role can use that warehouse, and I'm just going to now use it, and it'll have popped up in my worksheet view here, and there's a green dot next to it, which means that it's live. So that is now up and running. We can also see it in the warehouses view. So before, when we looked in here, there was nothing. Now we have our ETL warehouse. We'll just select that and go into the configuration. So the options we have in here, we can choose a size, go from extra small all the way up to 4x large, doubles each time in terms of resource availability, and also in terms of the cost. So you've got credits per hour here, and it's based on per second billing. Right? So you'll be spending on a extra small or any of the smaller sizes. If you only got them up for shorter periods of time, you'll be spending fractions of credits at that stage. So that's the size. We've got the concept of auto suspend, which allows us to suspend, basically power off the warehouse if it's not used, if there's no queries hitting it for a period of time, and then it go to it'll still remain there on our list of configured warehouses, but it won't be incurring any cost. And likewise, auto resume as well. As soon as a query comes in to a suspended warehouse, assuming the user has the right permissions, it'll activate that. And if it's a size large or below, chances are it's going to come straight back up within milliseconds. There's a pool of compute that Snowflake maintain that this will be configured from, so it's having to start up. It's not having to start up EC2 instances or anything like that behind the scenes. It's all there ready to go. Okay, so these are great cost-saving features, particularly in a warehouse that's used occasionally, or if you're doing a proof of concept or anything like that, where you want to keep the cost to a minimum. Okay. There's also a concept, it's not available in here, but there's concept of multi-cluster warehouses where you can actually have them scale out rather than just scale up like we've got on this one, and that can happen automatically as well. Okay, so we go back to our worksheet. We've created our warehouse, we've given ourselves access to it. Now we're going to do the actual data load itself. So that's that copy into statement you see there. What that's doing is that's copying into that table that we just created. So in the curation layer, we've created an events table. It's going to come from the ingestion S3 stage, and we put a path specifier on there just to make sure we only capture the events data, because if we capture the assets data, it wouldn't match up with our table schema, it would throw an error. Okay, and we're specifying the file format to use, which is this CSV format specifier that lets us know how to pass the file. Okay, so I'll just run that now. What that'll do is that's going to run through copying that data in. It does take about a minute and a half to run. So what we'll do is we'll take the opportunity to have a look at our history tab. So our history tab here is the history of all the queries that have run so far, and in fact it's all the ones that we've got permission to access. So as an admin, I can see everything that's happening here, some history in this list, and effectively it's showing current queries, ones that have succeeded, ones that have failed, and any query that we're looking at, we can click into the query ID, and we can not only see the actual query that was run, but if we click through onto the profile, we can see how it's actually planned the query within the system. It's going to be a little bit slow because it's running the query at the moment, so this might take a few moments to come up. But effectively, you can see the query plan from the point you kick off the query, and obviously you'll see that on completed queries, and it shows you the breakdown of the time spent based on each step of the query. Now this is just a load, so it's going to be just scanning data and inserting it. It's not very interesting to look at, and we'll come back into this one. We've got a query, quite a complex one that's run. Okay, so we'll see that's now 90% of the way through, which is good. That's nearly finished. So if we just switch back to the worksheet, and that's completed in the time that I was just talking then. So we've got 2,500 rows, which is one row for each file that we loaded. So that's good, and we've got I can't see any errors in there, which is good. We could do a much more thorough examination of that output, and there's a view within the information schema which also lets us see the load history. So if we want to do some analysis, or certainly if we're automating loads, we can then process that data to find out exactly if we've had any failures or not. We can also specify whether or not to continue in the event of failure by putting optional parameters to the copy into statement here. Okay, so a quick peep at the data. Let's have a look and see what that is like. Great, so that's looking like it should. We've got some IDs in there, we've got some values, numeric values, and we've got some epoch style timestamps. Okay, so that's our events data. Now that did take a while. Let's see how long that took. So if we look at the mini history we've got here on the worksheet, 1 minute 25 seconds. Now it could be that that's okay for us, but actually it might be we want to get that time down. We want to, either we're working in quite an agile way and we want to not spend our time sitting around too long, or maybe it's time sensitive for purposes of the downstream usage of that data. What we'll do is we'll just try again by bumping up the warehouse a couple of times. So this will be 4 times larger to go to 2x large. Okay, so I'm just going to truncate the table first of all, and that's just a metadata operation. It's just unlinking the metadata reference from that data that's stored. The data hasn't gone anywhere, the data's still there, and we'll talk about the history that's maintained within Snowflake a bit later on. Okay, but we've literally just unlinked it, so if we did a select now, it's just going to come up with 0 results. what I'll do is I'll create, I'll resize the warehouse. So if you see up here now, it's a 2XL. We've now doubled and then doubled again the size of the warehouse. And if I run the copy into, it's not exactly a linear increase, but pretty much, because it's just scaling to more compute. It's able to do twice as much, four times as much now. So it should take about a quarter of the time. I would expect this to take about less than 30 seconds, hopefully about 20-25 seconds. There is a bit of overhead, of course, so you will never see an exact linear scale down. But effectively, what this means is that if you double the warehouse size, you'd expect roughly half the time. So in terms of credit spent, it's about the same, assuming then you do stop the warehouse when you're done using it. So yeah, that took about just over 30 seconds, which is great, and to do the same result, and everything's gone in. So that was a lot quicker. So we're able to scale up and do that quickly. And again, this sizing up and sizing down can be automated. So if you've got a copy script, a bulk copy script that's going to run at a certain time, let's say every day, you might want to bump up the size of your ETL warehouse to cope with it at the start. So put an auto warehouse statement at the top, run the copy statements, and then alter it back down to the usual size for maybe the incremental imports that happen during the day. Okay, so we've got our event data in. So we loaded in from the stage into the table that we created, and we've just validated that, running that a couple of times on different warehouse sizes to see the scalability. So that's one set of data. What we also have is we have our assets data. Now, although they've put it in the S3 bucket for us, we're just going to demonstrate how we can put data in a different way. So we'll create this time an internal stage, which is, again, a staging area. And in terms of interacting with that from Snowflake, it's exactly the same as an external stage, except that all we do is we create it through the Snowflake interface, and it's managed by Snowflake. So we don't have to have an AWS account. We don't have to worry about IAM permissions and all that sort of stuff. It's all done by Snowflake. And what we'll do is we'll push a data file locally into that stage and then copy it into the assets table as a two-step load. So going into ingestion and then into curation. Okay, so let's just switch back to the worksheet. So we've got a file saved locally. So first thing to do is create a stage for it. Let's do that through the UI because we've not done too much of that. Go back to ZTS and stages. Okay, so there's our S3 stage. It's pointing out to our external S3 bucket. Let's now create a Snowflake managed stage as opposed to S3 or Azure external stage. Give it the name, and it's going to sit in ingestion schema. Okay, and hit finish on that. There we go. That's it. Easy as that. We've got a stage now that's available. We're an admin, and it's owned by the same role that we're using, so we don't need to worry about permissions. And there's not a huge amount on role-based access in this demonstration. We'll touch on it briefly when we look at the BI user, but there's a lot more we can do with role-based access than what we're showing here. Okay, let's just go to the worksheet now. So the next thing to do is to push a local file from my PC here into that stage. So what I'm going to do is I'm just going to start up the SnowSQL command line tool. So I can run that straight from my command line here. I've got that installed on my PC. It runs on PC, various platforms. Fairly sure it runs on PC, Mac, and Linux. And sorry, I'm trying not to talk while I'm typing the password, otherwise I get it wrong. And what that is a command line tool that lets you do anything that we're doing there through the worksheet. So any SQL commands can be run through here. The big advantage, though, is of using this is that we can also have access to the put and get commands, which you can't do through the UI or through platforms such as JDBC or ODBC, because the put and get commands interact with a local file system, which allow you to upload files into a stage and also to download them from a stage if you're doing unloads of data. So if I just go in here, let's just make that full screen. I'm just going to get rid of the webinar panel. Right. So there we go. So it's doing some type ahead for us, which is great. Tell which database we're going to use and which warehouse we want to use. Fantastic. And I just need to copy and paste this bit because otherwise it's going to go wrong. Let's see. There we go. So we've got the file locally. Just talk you through this command before I execute it. So we've got a file. It's in our D drive, which is potentially a bunch of files. I'll put a wildcard on there, but it's actually just the one file in reality. But that'll pick that up using that file-based URI specifier, and it's going to put it into the assets folder inside our internal stage. This is the internal stage we just created. So I'll just run that now. It's just going to I didn't specify any compression, so if it's not already zipped, I think it is, but if it wasn't, it would zip it by default unless we tell it not to. And it's also encrypting, so all data in flight and at rest in Snowflake is encrypted. There's no way to store unencrypted data anywhere in Snowflake. So that's now in our stage. If we go back to the worksheet and we just run the list command, that will tell us how many files and what they look like. And we've got this one here, just the one file we uploaded. There we go, that's fine. So that's gone in there. Okay, so we've gone, first step, we push the data into Snowflake, albeit just into a stage. What I want to do now is just run table creation. So again, similar to what we did before for the events data, a few more fields, and one that does jump out actually here is the attributes. This is the variance, which means we're going to store unstructured data in this field. And you'll see what that means when I push the data in. So I just copy the data into that table using a very similar copy into statement than I did before. And if I just grab the top 10 rows from that table, you'll see this is the data we've got, and that attributes field, which has got the variant type, because our source data is structured into an CSV, but because the assets can be of very different types. We've got some which are vans, cars, trucks. We've also got ships, laptops, drones, planes, yachts, all sorts in there. The actual attributes which make up what is a car, let's say, will be different to what makes up a yacht or a drone. So that's the unstructured bit. These are all specific to the type of asset, which is why they're stored in a semi-structured format like JSON. So a lot of systems will have a problem with this because they'll be different for each record, but Snowflake, we'll see how later on how we can query down into this JSON structure. But at least at this stage, it's detected it as JSON, it's formatting it nicely. We know it's valid and we can work with it the same as we can with the structured columns. Okay, so I just realized I didn't restart PowerPoint, everything else, but not that. So just bear with me one moment while I get that going, and I'll just pick up from where we got to in the slides. So we just, yeah, I didn't change that. 2, 3. Assets data. Okay, so we created our stage internally, pushed the data in, and put that into the table. So at this stage, we've got our events table curated, and we've got our assets table and the data in there. So third set of data is our accounts. So at the moment, this is all technical data from our technical system. We want to enrich that with some more commercial data, and that's going to come from Salesforce. So our assets are all linked to an account. If we bring that accounts data in, we can then merge that together and report on it in our BI platform. So that's what we want to do. So we've got some data in Salesforce. We're going to set up a table. You see a pattern here. We're setting up a curation layer table to hold that data in as similar to the source format as possible. And we're going to use an ETL platform, in this case Talend, just to bring that data in and to move that directly into Snowflake. So there's no ingestion layer involved here. Quite often we would use the ingestion layer as a stepping stone. I've just abbreviated the process slightly here for clarity in the demonstration. So what I can do now is if I switch over to my worksheet and make sure we've got the table created. So here's a table here, curation SF accounts. It's quite a long table because it's using every single field that's available to us in Salesforce. We're not dropping anything here, we're not dropping any columns, we're not mapping anything. We're keeping everything pretty much exactly as it is at source. So that table has been created. If I go into the Talend Studio now, so this is Talend Studio. It's running on my machine. This could also be run from the cloud. It's a cloud version of this as well. if I open up the demo folder, where are we? Ingest SFDC accounts to Snowflake. Okay, so this is a job. I'm just opening up a job now. It's going to take a few moments just to build that because Talend is a code generator, so it's storing the job definition and then it's now building this into Java code, so we can run it. And in fact, it's just got to fetch it out of the Git repository, so it's just going to take a moment or two just to pull that from Git and put it onto my screen. Of course, it's slower than normal because it is a demo, and that's how it works. Okay. Just check that's connected up correctly. That's fine. We're all good. Okay. So what this job is doing, very simply, making a connection to Salesforce, connection to Snowflake. Then the actual body of the job is just to pull the data out of the accounts object in Salesforce. The mapping component here is purely just to make sure the different data types are mapped together properly. There's some slight subtleties between the Salesforce types, Java types, and Snowflake types we need to make sure are mapped, but this just does it implicitly for us. We don't need to override any type mappings or anything. And then we're going to push that into Snowflake. This, by default, does a batch, a bulk load into, so it's not doing a transactional load. It's behind the scenes. This will be building data files and using the puts command in a very similar fashion to what we did using the SnowSQL command line tool, and then we'll just report on our output. So what I'll do is I'll just kick off a run. It's just going to build that job for us, and when it's built, it's just going to run locally. We could of course bounce this off a remote execution server if we needed to, but given these are both cloud platforms, we can run this from pretty much anywhere. If we were extracting data using Talend from an on-prem database, we could either run this on a server next to the database, or we can have a remote execution engine that's sitting again next to the data source, so we don't have to worry about access through firewalls. Just give this a moment just to finish off. There we go. So that's just built. It's running now. Was the scary bit, waiting for the errors to come up. There we go. So that's just finished, and that's just pushed the data now into Snowflake. That's okay. We'll go back here. What we can do is just have a quick look at top 10 rows to make sure the data looks okay. Again, we could examine metadata to work out exactly what's happened, but it looks good. We've got data in here. Pretty much as it is in Salesforce. In fact, there's the list of accounts in Salesforce. It's quite a clean view. I've not put a lot of extraneous information in here. All we need is things like the account name type and industry. I think we've got in here as well. So just let's do a bit of slice and dice against our source data when we're in the BI platform. Okay, so that was quick. We're going to go back to the slides, have a quick look at where we are. So we've got data into our accounts, and that now gives us 3 sets of data which we can start to bring together. So create a table for BI. Now we go up into the calculation layer. So far we've been working with data in the structure as it was in the source. Now we want to change that structure to a set of data that's more useful for analytics and BI. So we're going to build a full events table. We won't do any aggregation here. This will the same number of rows as we'll have in our raw events data, but we'll be flattening that against the assets and the accounts information which are coming up through from the curation layer. So we'll bring those together, and then we'll create another virtual warehouse which will let us query that data using a different pool of compute from the one that we use for ETL, and I'll explain again why that's important in a minute. So if we switch over back to the worksheet there, here's our table definition. It's table definition that we've got for the creation of the events table. Let me just check and see if I've got a slightly newer version of that, because I do need to push the dates on slightly. And I think I lost that in the crash, unfortunately. And let's just see if it's in here. Otherwise, it shouldn't matter too much. Did I save it in here? No. Okay, let's not worry. It'll be fine. Okay. So I'm just going to set that up. So what that's doing is that's joining together those three tables and forming a schema which will let us query that data. It's doing a create table as select, which means it's not only creating the table, but it's also populating it with the data. Just for speed, again, in a production environment, we'd have the table created, and we'd have some ETL or ELT routine that's going to be populating that on a regular basis from the source tables in batch or micro batch fashion. But this is there we go, successfully created. That was fairly quick. So that's now put the data in to the table as well, like I said. And if we do a quick query to see what that looks like, just pull off the top 10 rows. There we go. So we've got all the data that we need, not just the event, but what the asset is, who the account is, what's the type of accounts, what sector they're in. So actually, this is going to be really valuable now for us to use in BI. So now we've got that set of data. Let's create our warehouse. There we go. Creating a BI warehouse. That'll let us access that data from our BI platform. And I'm just going to give a quick aside now, actually, on permissions. So we've got a top-level role called sysadmin. The role that we're currently using is ZTS admin, which is an admin role local to this particular use case, this POC, whatever it might be. And the user that we're using is a member of that role. But because sysadmin inherits from our role, any objects that we create can be seen by any other admin, and that's quite important for the role-based access control model within Snowflake. We're going to create an even lower level role now, which again, our ZTS admin role will inherit from, but that will let us create a BI user with limited permissions. We don't want to use our admin user to access for BI, because they'll have access to all the low-level tables, and they'll be able to change stuff and drop things and all that sort of nastiness that we don't want lower privilege users to do. So we'll create a sandboxed user with a limited role. Okay. So I'll just run through that quite quickly. Again, like I said before, it's not masterclass on role-based access control in Snowflake. I'm just going to do this all in one go, in fact. And if we have time at the end, we'll see if we can pick up any questions you might have on role-based access. Oops, I forgot to change role. So I just need to elevate my role so I can do account-based stuff. In fact, I'll do this all in one go. There we go. So like I did before, I'm just going to lasso a whole load of stuff in the worksheet, and then I can execute it in one go. Okay, and remember to switch back to the previous role. So once I'm done with my elevator permissions, I've just gone back to the role I had. It's quite important. Otherwise, I'll end up doing everything as accounts admin, which is a super user level role, which no one else will be able to see the content of. Okay, so we've set up our BI user and our BI role. So what I can do now is just show how this is going to work. Setting up BI, we've got our table populated with data. We've got Zoom data set up, so I'll switch over to that in a second. And we'll look at how we can view that data. So I don't know if you're familiar with Zoom data. Zoom data is a BI platform. It's web-based, and it's particularly good for time series data and for real-time data and real-time analytics. So I've got a connection here, and I'll show you the connection I've got. Connection to Snowflake, and this just uses a standard JDBC connector. So nothing unusual here. We've just got a JDBC URL. We've got our credentials. That's the BI user and the password that we put in before, and that's saved within here. That's all set up, and that lets us then see which tables we've got within the platform. And because of our limited permissions, the BI user can only see the calculations layer, only that schema. So the only table it can see is this events table in calculation. It can't see the lower level tables, which is exactly what we want. Okay, and for speed, I created a dashboard earlier, and here's the dashboard. This is looking at the data that we've got coming through. We've got data from a few months which has been populated. This is, in fact, in live mode in Zoom Data. So if we were pushing data in a sort of a micro batch basis, and I have simulated that for the purpose of this, you'll see the number of events is going up all the time as the data gets pushed in. In fact, because we've gone off the end of the data set, that number's actually going down, but because that's a 60-day rolling. That normally would be climbing up, so possibly not the best demonstration here, but Zoom Data is constantly polling the database, but doing that in a very efficient way. In fact, you can see that happening here. Another use for the history view is to see, in Snowflake rather, is to see exactly what's happening to the database, how different systems are interacting with it. So if you've got a concern about a particular BI platform or analytics platform, or just a set of users and what they're doing, you can go into the history, you can see all the queries that are being run. You see it's queries coming through from Zoom Data here, but it's actually putting very tight date parameters on them. So it's looking at very small slice of the data each time. Okay, so that's Zoom Data. Again, not a Zoom Data demo, so I won't go through anything more there. But just to show now, what we've done is we've pushed all our data into the system, we've transformed that data, and we have now presented that to analysts, data scientists, even if they want to look at the raw underlying data, and it's available now end to end. So we've been doing this, I don't know, 45 minutes plus stoppages, and we've now got a usable system, albeit without the bells and whistles we'd expect from a full production implementation. If this was a proof of concept, you know, we'd be up and running before coffee break on the first day, which is really good. So let's look at a few other things. We've got a few more minutes just to look at some other aspects to this. The first thing is just a note on concurrency. So we set up an ETL warehouse. So remember, the warehouse is the pool of compute resource that we can use to access the actual database itself. So our ETL user, in fact, we're using the admin user for simplicity, but we were using the ETL warehouse to load data. That is a completely separate warehouse from the BI warehouse that we set up for reporting. So it'd be possible to run a complicated analytical query. Let's say we've got one here. Where is it? In the worksheet. I've got a query here. Make sure we're using the right warehouse. I'm just going to turn off the results set cache, and I'll explain why in a second. There we go. And I've got this analytical query which actually does some. It needs to do a full scan because it's looking at every single row, and it's using functions like lead and lag, which are windowing functions, which means it's got to compare every row to the previous one or the next one. So it's doing quite a lot with the data. So we're going to force it to be quite busy. There we go, and that's kicked off. And if we go back into Zoom Data, let's just go back in. This is in live mode, so Zoom Data is constantly querying the data. There's no caching happening here. If we just zoom into industry, let's say, we can actually, it's still very usable, even there's a fairly large set of data, it's a few billion rows. I don't know, customer account ID, there we go. So we can actually query this very, very quickly, even though that big query is ongoing, that big analytical query is happening at the same time. In fact, that did finish halfway through that. Because we're using two different warehouses. So the analytical query was using our ETL warehouse, and the BI one was using the BI warehouse. So we've got that concurrency. If we had another set of users coming in wanting to do some computer science, some data science, we have some users wanting to do another project, they can have their own warehouses to do their own compute on and still access the main set of data. That's not a problem. We don't need to copy the data around. And that does mean that we can not only segregate them from impacting one another in terms of the usage of the system, but also it's great for cost allocation as well. So if we've got different projects using the system, we can apportion costs because we can get a breakdown of the billing by the different warehouses used. So that's another great feature. Here's another thing we can look at, a development sandbox. So let's say now we've set this up and this is working end to end. We've got some users looking at these reports, but we want to make a few changes. We want to try some stuff out. We're obviously not going to use the main production database for that. We want to create ourselves a dev environment that we can use. Very quick to do that in Snowflake, because what we can do is we can just do a quick clone. It's a zero copy clone, which means it takes a copy of the database, and all the metadata, but it refers back to the original underlying blocks on storage. Now that's just up to the point that we make changes to those in our clone, and once we make changes to our clone, it creates new data for that, but only for the bits we've changed. So it's only incremental additions in storage rather than having to duplicate storage of the whole system itself. So now as a development user, we can play with our clone, and that's not going to impact at all on our main production system. We can do whatever we want, lock bits out, add bits in, and that's not going to have any impact. And once we're done with it, we can just drop that clone, and that just goes away. So we don't need permanent dev environments or permanent test environments. We can stand them up as needed. We can automate the creation of clones, use them as we want, and then drop them when we're done. Let's just see that in action. I'm just going to turn the query cache back on. Yes, I did. So I was explaining about the caching. If you run the same query, exactly the same query twice, or any number of times, in fact, within the same 24 hours, any subsequent runs will come straight out of the cache. So results of every query are cached in a result set cache in Snowflake. So if you run, so for example, if I run this query again, if I run this, in fact, I'll just switch the cache on. So I'm going to run it once. It's going to take about, I think, 16 seconds it took last time just to run, because we had the cache switched off. But what you see is when we run it for a second time, so that's the first time, and second time, 62 milliseconds. So you see there's the two items in the mini history, 14.6 seconds for the first time, 6.2, same query, comes straight out of the cache. Okay, but for that particular demonstration, that wouldn't have been any good. We wanted to show it actually running. Okay, that's caching. Let's make sure we're using the right role. Okay, so let's create a clone. I'm going to call it ZTS dev Alex, because that's the name of the user I'm using, and I'm going to switch to it. So let's run those two statements. And again, because it's a purely metadata operation creating the clone, it comes back straight away, having finished. And if we switch to our databases view, you can see there's the, and it's got all the objects in from the original. So, and it looks like it's a full clone. Right, okay, so let's have a quick look at the breakdown of assets we've got in there. So we've got all sorts of different types of assets in our assets database. What we need to do for whatever we're doing here in our bit of development is create some test data. So I'm just going to insert 5 test assets in there, which I'll need for what I'm doing. And let's just have a quick query to make sure they've gone in. There we go. So number of assets 5 over here. And if I just run the same query against our production database, so I'll just do a fully namespaced object there to say I want to make sure I'm getting the assets table from the curation schema in the original production ZTS, just to make sure we haven't impacted our production environment. No, we haven't. There we go. So that data I've just inserted into our clone that we've created. Another thing we can do with Snowflake is work with semi-structured data, so JSON data. So when you've got a structure such as this, where you've got objects and sub-objects in JSON, we can actually refer to those using a colon notation in the SQL. So we can the make model, and of course we use JSON path here to access sub-objects. There's all sorts of other stuff you can do, like iterate through arrays and do typecasting within JSON to make it much more powerful. And if we see that in action, here we go. So if we just first of all look at the data. So here's what the attributes looks like. So if you remember, this is the type specific information against each asset. So for a car, we've got things like engine information, make and model, what's the registration number, year of registration. There'd probably in real life be a lot more stuff than that, but that'll do for now. Let's show how we can query then into that. So first of all, let's what the top 10 makes and models of cars. So we're going to filter down our assets just to include cars, and we're going to pull out the make and the model, and we're casting these to string, because when you pull out the raw values from JSON or other semi-structured data formats, it doesn't know what type of data that is. So it'll just put quotes around it and wait for you to cast it to a particular type. So if we run that, there we go, Ford Fiesta, 25 in this small set of data we've got. So that's our top 10 makes and models. Let's do something a little bit more tricky now. So what's the average year for vehicles with a GG prefix? There we go, 2013. So now we're putting the, we're not only interacting with the semi-structured information, we're also doing some aggregation on that as well. Okay, and we're using it in our where clause. And then finally, a good way of working with semi-structured data is to build it into a view, or even to do a create table, a select type of statement and push it into a table. But here's a view where we're actually creating a view called cars, which is just the cars from our asset data, but we've exploded out the different attributes from that attributes into their own fields. So if I run that now and then interrogate that view, you'll see we've now got columns for things like year, age, make and model, trim level. They're all broken out. So if we now hooked up our Zoom data platform to this table, we could do analytics on the data that was previously unavailable to us because it was hidden within those JSON objects. So we've brought that out into a view, and if views aren't performant enough, you can push this into a table as well and work with it that way. Okay, so that's working with the data. Now that's everything I wanted to actually do on my clone. So I'm just going to drop my clone. That's all we needed to do to drop it. If we go back to my, oops, there we go, databases. Yeah, so you see the ZTS dev Alex is gone. We've dropped it. But accidents happen. And a great feature I like of Snowflake is we can undrop. So if we have a quick look in here, ZTS, there's only one ZTS database, but in our show databases command, we can put history. And that actually queries not only the active objects, but all the objects that have ever existed. And you see, actually, there's 2 copies of ZTS dev Alex in there. I've done a run through previously, and it's still in there. But what we can do is use the undrop command to bring back the most recent one. And all that does is that just switches the metadata to say, actually, we still want this. And if we go back to the databases view, it's come back. So undrop literally just reverses a drop operation. Now the data isn't stored indefinitely. It's stored for anything between 24 hours and 90 days, depending on the level of plan you have on Snowflake and the level of configuration you've set that to. Because of course you're storing more data with more history, and that does have an impact on cost. But there's other things we can do with this history as well. So if we just make sure we're using our production system, first of all, so I'll just switch over to production. How many cars we got? 186 cars in our assets database. Let's accidentally delete them all. Okay, so someone has run a rogue ETL script, or something's run, or someone's got access to the wrong database, and they've accidentally deleted something they shouldn't have. So they just deleted all the cars effectively from here. Look, there's none left. Number of assets 0. That's no good. What we should probably do is bring those back. So what we can do is we can actually have a look at, so we can do that same select operation, but by inserting this at statement, we can say not just querying the data as it is now, as with most SQL statements, but actually what it looks like at 5 minutes ago. So offset minus 60 times 5, so 300 seconds in the past. We can also put a specific time value in there, so we could put an absolute value, or we could actually say at the point either at or just before we did a particular SQL statement as well. So if there's a particular statement we want to reverse, we can grab the ID of the query and do it before that. So there's different ways of doing this. So we can see that 5 minutes ago we still had 186 cars. Yeah, like I said, we can do it before point in time. And if we grab the statement ID, we'll see, just bear with me, just grab this from the history. So what I just need to do is just move Zoom data off there, because otherwise it's going to keep filling up my history. So my history view had got filled up by Zoom data, constantly polling for updates. So all I've done is I've just done a quick filter to filter out that, so I can just see the things that I'm doing. There's my delete statement. Just want to grab the query ID so we can. There we go. So all I'm doing is inserting into assets from a select, and that select is all the cars that existed before I deleted them, effectively. If I run that should, there we go, that's inserted 186 rows, and if we just look at the current state of that database table, 186, so they're back again. So we've recovered from that failure, which is good. And if I just go to here, in terms of a recap, what we've done, we had some stuff in S3 and some data. We've set up Snowflake. We've created a database. We've created some virtual warehouses for compute. We've pulled the data in and processed it through the database to form it into a set of tables that we can work with. And we've put some data into Zoom Data as a BI platform to show how we can work with the data using a separate user and resource pool. Okay, that's all from me. I think we've got a bit of time now for questions.
Yeah, thanks, Sam. That was brilliant. One of the questions that came through that I think you demonstrated later was for heavy lifting and data transformation. Can you integrate a Snowflake storage layer with ETL like Talend? And I think you've demonstrated, obviously, you can.
Yeah. I mean, certainly, if you're pushing data into Snowflake from a tool like Talend, there's a couple of different ways. You can either use the built-in native connectors, which will then it pushes it into a structured table, so it needs to be structured data, but it does do it in an efficient way as a bulk load. So it does go via the stage and do it that way. Alternatively, you can just push your data into S3 or into Azure Blob. And then orchestrate the copy commands from one to the other. So if you did want to have a separate external staging area that you manage in Amazon S3, let's say, you can also do that. So Talend, for example, has commands to work with S3. So you can extract your data from the source system, you bundle it into compressed delimited files and push those onto S3. And then as the next step, orchestrate running a copy into command using the Snowflake components, but in that case, it's not actually transferring the data, it's just telling Snowflake, copy it from there into that table. There's a couple of ways of different ways of doing that.
Excellent, thank you. One of the other questions was about roles and permissions, and the question was, can Snowflake roles include specific role level data rows?
So if that's referring to role-based access, yes, there is possible to do role-based, row and column-based access using the role-based access model. So it's not something we can go into in great detail here, obviously, but that's something certainly there's documentation on. I'm happy to have a separate session on role-based access and how we can do row and column level security within Snowflake, but it's definitely possible.
That's great. And then another question was just in general, what is the link between Datalytics and Snowflake? Obviously, we're a Snowflake partner. We're the first Rockies partner of Snowflake in the UK. But Sam, maybe just in general, you'd like to just explain really what we do with Snowflake.
Yeah, sure. So we not only offer Snowflake services, we also resell as well. So we're a reseller for Snowflake. But what that means is that we can work with organizations from the point where they're starting to think about evaluating Snowflake, or maybe they're going through some sort of RFP process. We can help with that process. We can help with any proofs of concept that they might want to do. And be a single point of contact for all technical and commercial issues around using Snowflake, through to the point where if an organization decides to purchase, we can handle that, and we can provide services to set up and provide training and support throughout the life cycle of that engagement.
Excellent. Yeah, I think that about covers it. One of the questions is, we use MicroStrategy as our BI tool, and they want to know if that's supported by Snowflake.
Yeah, I'm actually working on a proof of concept with another company at the moment, which is using MicroStrategy. So I believe it is supported. In fact, Snowflake has JDBC and ODBC connections, so generic connectors, which covers just about any BI platform. They'll pretty much all support either JDBC or ODBC. So Power BI, Tableau, Zoom Data, like we saw, they all support Snowflake either with a native connector or just using a generic connection.
That's great. And then the last question in my queue so far is if you could just briefly go over the roles and access controls. Specifically, there was a question about there was an account admin that you showed. So the question is that a super admin? There seems to be sysadmins as well. So is that different from the super admin or the account admin?
Yeah, sure. So without, again, going into huge amounts of detail on role-based access control, Snowflake uses a hierarchical model for roles. So every role has to be inherited by another role, which means that if you create an object, so let's say I'm a standard user and I've got access to create some objects. If I create them, I'll be creating them under the role that I'm currently using. So maybe I'm using a user role. But because my user role is inherited by an admin role, any users with that admin role can also interact with those objects I've created. So it does mean you don't get any orphaned objects in the database. And there's other advantages, of course, as well of using a hierarchical model. But in terms of the specific question around account admin and sysadmin, these are default roles that are built into Snowflake. So account admin is the topmost role, and typically you'd only ever use account admin to do account level functions. So setting up users and roles, account level stuff, setting up data shares, which we didn't cover data sharing here in this demonstration, but that's another thing that is done at the account admin level. So you normally have very few people would be given access to that role to use. But that role does inherit then the sysadmin role, which is a slightly lower level of admin, but still all technical operations can pretty much be done by sysadmin. So creating any objects in the system, any databases, all done under sysadmin. And again, it's a role you'd use to do top level admin operations. Once you start to get down inside a database, you'll generally have more specific roles which you would then create. So rather than using the default roles, the built-in ones that I've just said, you'll have some specific roles which will then inherit into the sysadmin role. So yeah, it's not very clear. I probably need some diagrams and stuff to go through it properly. So maybe we'll have a separate session on role-based access. But yes, account admin is the top level account level role for doing administrative functions at the account level, and then sysadmin is more of a technical admin role.
I think that's a great answer. I think there's also some documentation online that's pretty accessible if you just Google Snowflake getting started and just search for roles or managing your account. I think there's some very good documentation that sort of explains the different roles and how they're set up and how you actually go about configuring those roles. Another question had just popped up. Sam, would you be able to provide us with any example use cases for when you would use external storage instead of using Snowflake storage?
Yeah, absolutely. So with external stage, basically this gives us the opportunity to hook up Snowflake to an external set of data. So let's say we've got a project that's already running and it's pushing data out into an S3 bucket. Rather than try and transfer that data across into Snowflake as files in a stage, we can just create an access point. So let's say a set of IAM permissions. So Snowflake can connect to that S3 bucket, and that will then see that as a stage, and it'll have access to all the objects within that bucket and be able to then process them and work with them as if they were in its own internal stage. So we don't have to move stuff around, we don't have to create new storage, we don't have to move huge amounts of data, particularly if we've got terabytes and terabytes of data already in blob storage or in an S3 bucket. we can just hook it straight up. I mean, the other side of the coin is if you just want to push some data, so let's say you've got some files locally on your PC, you're doing a proof of concept, or you're using an ETL platform which is pulling the data out of another system, and you want somewhere quick and easy to stage the data into. You don't want to have to sign up for an Amazon account if you don't already have one, and create an S3 bucket and hook it up that way. You just want to push it into a stage. So in that case, you can use a managed stage within Snowflake. It's literally two boxes on a form to create, or one very short line of SQL to create that. And then you're good to go. You can use the SnowSQL tool, use the put statement to push files in from a local PC. You can push into there from ETL platforms as well. We'll be able to interact with it. And that does give you the opportunity then to have your staging area, but not have to manage that, so that the whole management goes away. So there's advantages and disadvantages, I think, of using both approaches. But typically, you'd either want to use an external stage for existing sets of data, or where you want to manage that outside Snowflake. Otherwise, if you don't want the management and you want it to be quick and easy, you just do a managed stage within Snowflake. Hope that's answered the question.
I think that answers it. That's all the questions that I have in the queue. So if anybody has any more, please feel free to send them in now. Otherwise, if you think of some after, don't hesitate to send them across to us. I think I mentioned before, you can always email sales@datalytics.com, and we'll pick up those questions and respond to you quickly. As I've said before, a recording of this presentation will be made available by email to everyone who registered, and that will come out tomorrow, so you should be able to see that in your inbox tomorrow. For any other information, or for the presentation files, or for any of the scripts that you saw that you would like to test or see, we can make those available upon request, so just email sales@datalytics.com. And I think that concludes the presentation. Anthony, did you have anything that you wanted to say in closing?
No, that was great. Thank everyone for their time, and done well. Thank you.
Cheers. Thanks.
Cheers, Anthony. Okay, and thanks everybody for joining us today. Have a great rest of the day, and hopefully we'll speak to you soon. Thanks very much.